We have studied all of the types of conic sections already. There are 4 types of conic sections: circles, parabolas, ellipses, and hyperbolas. So we have studied each of the types, but in all of our previous lessons, they were all centered right at the origin. And so every day I was saying, for today, our center will be at the origin. Well, today is the day that they all move. And since they all move in the same way, we do that all together. Today we're going to work on writing equations. And then in the second part of the lesson that we'll do on Monday, we'll talk about how to graph. On your notes, not on the overhead, but on your notes, there's a chart with all of the equations. This is the chart that will be provided for you on the test. So you'll have all of the forms of the equations there. These equations are the same as you had on the individual days, except that in our parentheses on these, we have some h's and k's, which weren't there before. And that difference of the h and the k is what causes the center to move. So if h and k were 0, they wouldn't need to be there, and we'd be centered right at the origin. But today, that center is going to move. So to write an equation for a circle, I'm going to look up the equation in the chart for a circle, which says x minus h squared plus y minus k squared equals r squared. And then in the end, all that should be left are x and y, and everything else should be numbers. The center is hk. So I can plug in a 9 in h's spot and a 3 in k's spot. The radius is r. So I can plug in a 4 in r's spot. And for our final answer then, we just need to square that 4 and make it 16. We don't want to square it out or anything like that or try to solve for any of the letters. This is standard form, and that's the way that we want the final answers in standard form. So we need to plug in the center as h and k and plug in the radius as r. Questions? Try that base equation again. X minus h squared plus y minus k squared equals r squared. H and k are the center. We need to be careful when we plug in the h this time. Why? Because it's a negative and the equation's already subtracting, so that means this is really going to be x plus 2 squared and y minus 3 squared. 7 is our radius, and in our equation we want that squared. So that's our final answer. Questions on circles? Next one is a parabola. So in our chart we have 2 different equations for parabola based on whether it's horizontal or vertical. So you don't have to graph them, but I find that to be the easiest way to determine what direction this is going to be facing and to find some other important values. So I'm going to plot out a sketch of what we're told. We're told we have a vertex at negative 2, 1. So I'll plot that point and mark it with B for vertex. And a focus at negative 3, 1. A parabola goes through the vertex and opens around the focus. So that gives me an idea of what it looks like, and I see that it's horizontal facing. So then in the chart, I choose the form of the equation that's in the horizontal column. Which is this. Something that is different about a parabola than all the other conic sections is that a parabola does not have a center. So h and k in the parabola refer to the vertex. For all of the other ones, hk is center, but a parabola doesn't have a center, so h and k are the vertex here. So I'm going to have y minus 1 squared. I'm going to leave that blank in the front, and we'll deal with that in a minute. And x minus negative 2 gives x plus 2. In the end, it should just be the letters x and y left, and everything else should be numbers. So we have to figure out what number to put in for p. P is the distance from the vertex to the focus, and it's directional. So in the picture, from the vertex to the focus is a distance of what? Negative 1 being directional. So it's a length of 1, but since it's heading in the left direction, that's our negative direction. Remember, left and down as being negative, right and up as being positive. So our p-value in this one is negative 1. So we'll plug a negative 1 in for p. So that gives us negative 4 as our coefficient there. Okay. So for a parabola, h and k is not the center because we don't have a center. It's the vertex. P is the distance from the vertex to the focus, and it's directional. Questions? Try the next one. Okay, so I'm going to begin by plotting the points to get an idea of how this thing is directed. So I have a vertex at 3, 2, and a focus at 4, 2. So this is once again a horizontal facing. So if that focus and vertex were above each other, then it would be the vertical facing. So for horizontal facing, we have y minus k squared equals 4px minus h. Our vertex is our h and k. So we're going to have y minus 2 squared and x minus 3. P is the distance from the vertex to the focus, and it's directional. So from the vertex to the focus is a distance of positive 1, since it's in the right direction. So in this problem, P is 1, so that front multiplier is just 4. What if we were given our vertex and a directrix, but not a focus? How would we know what P is?
Because the directrix is just the opposite way as the arrow.
The directrix is the same distance away, just in the other direction. So whatever that is, that would be P. Same distance away as that focus would be on the other side. Okay? So if you're given a directrix, you're just given the other side of the picture, but the focus should be exactly the same distance away, just on the other side.
It's still directional.
It's still directional, but in this one, if we thought about where that focus would be, this one would be a positive p-value. Always think of up and right as your final parabola is facing. If your final parabola is facing up or right, you should have a positive p-value.
So for parabola that's not on the actual, the center of the axis, is the directrix just however the distance away in the other direction?
Yes. Yep. So the directrix is the distance from the vertex, but in the opposite direction is the focus. Next conic section to talk about is an ellipse. For an ellipse, there are horizontal and vertical equations given, but in general they're the same. They're both x minus something squared over something plus y minus something squared over something equals 1. So we have some blanks to fill in. With an ellipse, the difference in the equations for horizontal and vertical are not as big of a deal. Both of them start with x squared and then y squared.
I have a question just really fast about the directrix on the last one. So is the directrix the distance from the new vertice or point?
the directrix, the p-value is the distance from the directrix to the vertex.
Okay, so it's not like the directrix is from 0?
Not from 0, from the vertex to the directrix, yeah. So for this one, once again, I'm a visual person, so I think the easiest way to see it is to actually draw it and not try to hold it in my head. So I'm going to plot out these points. 0, -3, I have, it says a covertex, and -4, -3, I have a covertex. Then at -2, 0, I have a vertex, and mine has a typo, but yours is good. That should be a -6 for my other vertex. So I get the 4 points around that I could connect to make my ellipse. So H and K, or what goes in those parentheses, is supposed to be the center, but we're not given the center. But the center should be right in the center or middle. So if I connect together those vertices and covertices, that should let me know where my center is. So where is the center of this thing? -2, -3 is our center. It needs to be in line with the vertices and the covertices and right in the middle of everything. So that's our HK. Remember to be careful of those double negatives. This makes x plus 2 then, and y plus 3. And we'll think back to how graphing worked from the equations. If I had a number underneath the x squared, what did I do with that to graph it? So if we started with the equation and went to the graph, what did I do with the number that was under the x squared? Took a square root of it, and then how did I plot it? If it's under the x, it should tell us about sideways movement. Okay? So what we're going to do is in our graph, we're going to look at the sideways distance from center to the edge. And how far is that? 2. And since that is an x element, it's going to go under the x. But everything becomes squared in the equation, so that's going to be a 4. You could also think of it as being a -2, but when you square it, it'll still end up as being positive. So negative, positive doesn't so much matter since we end up squaring anyway. Then from center up to the edge in a y direction, how far is that? 3. And that goes with y, so we'll square it and put it with y. Mm-hmm.
Is it just a coincidence that the numbers you have in the equation there?
It is just a coincidence that the bottoms are the squares of the tops, if that's what you mean. Yes.
Because there was 2 squared in that.
Right. Just a coincidence because one of the vertices and one of the covertices are still on an axis, so that's why. If it was completely floating in the middle of a quadrant, that wouldn't work.
For the, it says horizontal and vertical.
Mm-hmm.
How do you figure out?
It doesn't really matter. This one's vertical because it's taller, which just means that the bigger number should end up under the y. But otherwise, there's really no difference in the equation. So I don't really so much worry with an ellipse, whether it's horizontal or vertical. I just leave blanks for the h and the k and for the bottom numbers. We have another ellipse question, but I'm not going to set you free on this one because we're given different information here than the last one. So this is a different type of question than the last one. So we're going to start by plotting what we know. On this one, I have foci at 3, 5 and 3, -1. And vertices at 3, 6 and 3, negative 2. I wasn't told anything about how wide this guy is, so I don't really know how wide. So I'm just going to kind of sketch it in there, but I don't know anything about the width. So our general form for an ellipse is going to be x minus something squared over something plus y minus something squared over something equals 1. And we have the 4 blanks to fill in. On the last problem, we were given covertices, but on this time, we were given foci instead. So we can still solve it. It's just going to be a different type of problem. What goes in the parentheses is the center, the h and the k. So for center, we need to figure out where is the exact middle of this thing going to be. It should be in line with the vertices and right between them. So what is the x-coordinate going to be? 3, because it has to be in line with them, and everything is over at x is 3. Then, what is exactly halfway between 6 and negative 2? Positive 2. So our center must be at 3, 2, so that it's right in the middle. We're thinking about finding a midpoint there. So in our very first lesson, we learned that a midpoint is the average of 2 points. So average 3 and 3, that gives 3. Average 6 and negative 2, and that gives positive 2. So we're finding the average of those vertices, or the midpoint of the vertices, will give us the center. So we plug those in the equation. The center comes from averaging the vertices, or finding the midpoint of the vertices. So if I find the midpoint between those 2 points, and we learned in our first lesson, midpoint is average the x's and average the y's. So 3 plus 3 divided by 2 is 3. And negative 2 plus 6 divided by 2 is 2. Then, I only know about one direction here. I know from the center up to the vertex. How far is that? 4. Because our center was at 2 and our vertex is up at 6. Everything becomes squared when it goes into the equation. So I'm going to square that and get 16. Put it under the y because it's a y direction. Since it's up and down, that talks about y's. I don't know anything about sideways here, so I don't have something to put under the x. But I do know about the focus. So in your chart, there's an equation that talks about the focus. And that equation is c squared equals a squared minus b squared. And that will be in the chart on the test as well. You don't need to memorize that. C is the distance from center to focus. We can remember that because there's a lot of C's in that sentence. C, center, focus has a C in it too. Okay, so C, center, focus. So the distance from our center to our focus is what?
3.
So that is our C value. Equation, I'm going to put a 3 in for C. A squared is what we already know in the equation, and B squared is what we need to know in the equation. So C is always center to focus. A squared is what we know, and B squared is what we need to know. So 9 equals 16 minus B squared. Subtract 16 gives negative 7 is negative b squared. So 7 is b squared, and that's what goes into the equation. Okay, so your center is your midpoint of your vertices. Distance from center to focus is c. So if you're given your focus then you need to use that secondary equation to be able to get one of your values. Questions? Our next problem is about a hyperbola. A hyperbola is in many ways the same as an ellipse. We'll start by plotting what we're given. So I plot out the 4 points, and a hyperbola should have 2 branches that go through the vertices and open around the foci. So when plotting these points, I can tell this thing is vertically faced. So in the chart, the vertical hyperbola means that y comes first. In a hyperbola equation, we subtract the fractions. So since this is up and down facing, that means the y comes first. If it was side to side facing, that would mean the x would come first. It would be horizontal then. The center should be the midpoint of the vertices. So exactly halfway between the vertices, or taking the average or midpoint of the vertices, gives me a center where? 5, 0. The average of 5 and 5 is 5. The average of -4 and +4 is 0. So that center right in the middle of those vertices is at 5, 0. That's our h and k. So that's what we plug into the parentheses. 0 with the y and 5 with the x. If you didn't write -0, if you just wrote a plain y squared on top, that's totally fine. And that's how the answer key in the book will do it for stuff like that. But if you write the 0, that's absolutely fine too. From the center to the vertex is a distance of what? 4. We square everything when it goes into the equation. So it's going to become 16. And which letter does it go under? The y. Because it's in a y direction. It's up and down like y. So that goes under the y. We don't know anything about side to side, so we don't know what to put under x. But we have the focus. So from center to focus is how far? 6, and that is our c value. For a hyperbola, the equation is c squared equals a squared plus b squared. Once again, that's in your chart, and you don't need to memorize it. So c is 6, that distance from center to focus. A squared is what we already know, and b squared is what we need to know. So 36 equals 16 plus b squared. 20 is b squared, and that's what goes in the equation. Questions?